Thank you, Dr. Shahjahan. Thank you very much for this very nice introduction. Thank you, Principal Sir. Firstly, thank you for inviting me for this wonderful and good luck learning amazing things over this week. Uh, I was discussing with Dr. Shahjahan about the topic that I should present. We were discussing if we should present something about 5G and what it is, but I suggested him that maybe there are several talks where you must have heard and where you will hear what 5G is in terms of physical layer or MAC layer, whatever. What I really wanted to present was what has India been doing in terms of 5G. I'm pretty sure the content that I'm going to present, most of the folks may not even be aware of. I mean, we usually say that India is not doing much and India is just trying to use technologies from other, and we say India is lagging behind in technology, like using of a particular technology, saying that we are behind some advanced developed countries. But I wanted to dispel that notion using this talk and to tell you and bring forth to you what we have been doing over the last 4 to 5 years in India with respect to 5G. I just want to save my bandwidth and don't want my speech to be cut off. So I'm just turning off my video if that's okay, Dr. Shahjahan.
Yes, sir, please.
Yeah. So I'm sharing my slides. So I believe you can see it now. Hello, can you confirm that you can see my slides?
Yes, sir, it's visible.
Yes, sir.
Okay,
Yes, sir.
thank you so much. Thank you. So the title of my talk, as I rightly just mentioned, is about India's 5G journey. So as Dr. Shahjahan mentioned, I'm very fortunate to be involved with two prestigious institutions, I would say. One is IIT Hyderabad, the other is Vysig Networks. Vysig is a startup that was incubated by a professor in IIT in 2016. And I have been associated with it since the end of 2017, early 2018. Over the course of this talk, I'll tell you what we are doing everywhere. So this will be the outline of the talk. I will generally tell you about what is India's perspective about 5G, what is in it for us, and then I will tell you what we have been doing from a standards perspective, and I will tell you why it is important. And I'll also highlight all the contributions that we have made with a group of Indian researchers at different forums that Dr. Shahjahan mentioned. Like 3GPP, International Telecommunications Union, which is a UN body, and the local body, which is TSDSI. And then I will give you an R&D perspective of what we are doing in terms of developing 5G at different places like IITH and Vysig, and what really India should do next. So currently in India, there's a lot of buzz that's happening around 5G. And with all this Atmanirbharta and the Chinese influence that's happening, I'm actually very glad, and the group of researchers that we are working with, we involve very closely with the Department of Telecommunications. We are very glad that some jolt like that has happened to India. I'm sorry to say, I mean, it's security wise, it's a different thing, but what has happened is that it has awakened several minds across different organizations. What we have realized is, at least from a government perspective, India has realized that it is very, very crucial that technology ownership is mandatory for a country to maintain national interests and national security. It could be 4G, it could be 5G, it could be IoT, whatever technology it is. We have realized that it is really not good to depend on third-party countries or the technology developed by outside people for deployment within the country or even across the border. So government has been working aggressively. Trust me, when I say aggressively, it is really aggressive. And we have seen a lot of positive things happening in the government, a lot of policies to enhance the current R&D capabilities, be it the PLI manufacturing benefits that the government is giving, Or for instance, the BSNL tender that if you might be following, there are positives, there are negatives, but we feel it is the step taken in the right direction by the government. There is a huge thrust on IP creation by the government. There is incentives that the government is giving, and the actually, if you must have filed some patents in the past, it would have taken several, almost like 10 years in India to get a patent granted. But nowadays, we are actually seeing patents being granted within as less as 2 years. The commerce industry has risen up to the situation. They are helping all the researchers in India. India has built up a huge portfolio of patents in this cutting edge technologies. When I say India, I'm referring to Indian researchers and Indian born companies. See, I mean, there could be Qualcomm filing patents in India, but really, I think the patent is still held by Qualcomm in India. It probably won't help India as much. What I mean by IPR creation help is Indian researchers and Indian born companies and Indian startups filing a lot of patents. The government is, I don't know, I have seen a huge change. You should really be happy that India is moving in the right direction. Things have changed massively. And there is a lot of focus in DOT, Department of Telecom, MIT, all the electronics and communication related government departments, where they are helping us to influence standards organizations outside India as well as within India to align India's requirements with the global ones. So this point I will cover in great detail and tell you the struggle that we have been facing and working towards over the last 3-4 years. So why you might ask me why? What should India do? What is so unique about India? So these are some numbers that I've taken from a TRI report that came up in May or June. So it says this is the mobile broadband is the prime source of internet access in India. So there are different kinds of broadband, right? There's a wired broadband, there's a mobile broadband, and a fixed wireless broadband. Wired is typically like our DSL connections. If you remember, there's a copper wire. We used to connect our cable modems, right? Then there is mobile broadband, which is typically what we have on our cell phones these days. And then there is a fixed wireless broadband, which is gathering steam in 5G especially. I mean, there's like two wireless devices talking to each other over wireless access, but then inside your home, you can connect to that access point. And it has been identified by TRI that mobile broadband is the like our cell phone based thing is a prime source of internet access in India. I would say things have turned around after Jio. You like it or not, Jio has been a big boon. I mean, this is my personal opinion. Not many of you may agree with me. There are controversies, but I think Jio has done the right thing for India. We are now on a global map. It has helped us a lot. Honestly, I think this COVID situation, we may not have been able to pass through as easily, at least most of us, working from home or teaching classes without such a great mobile broadband network in India. It is amazing. I would really like to thank Jio for it, for bringing a change in all the operators across the country. And so if you see this, the number of wired internet subscribers are somewhere around 22 million versus wireless internet subscribers are 700 million in India. Amazing. And if you see, there's an equal share of urban and rural subscribers. So if the total number of wireless subscribers are somewhere around 1.1 billion, now you might see, I mean, just don't count the population. Several people may own 2 SIM cards or 3 SIM cards. So maybe the people is not exactly what this first line here means. It's just a total number of wireless subscriptions. So urban is somewhere around 600 million, like 60 crores, and rural is around like 50 crores, not lagging behind. What does it say? That there's a big share of rural population. You might think, oh, who's staying in rural areas? What are they doing? Are they even going to use? No. Look at this number. Rural is as much important as an urban scenario to ensure coverage, especially in this COVID situation, right? Most of you must have moved back to rural areas. How do you think you were able to manage to work? There was a lot of rural infrastructure that was required to ensure we all worked successfully in this situation. That's why the number of rural subscribers is not far lagging behind in India. But these numbers may not be the same for a developed country like US. there could be like 10 times or 20 times difference between an urban and a rural subscribers in US or UK. I mean, some of you who may know about the rural-urban divide in the developed countries, you see very few people staying in rural areas and maybe a majority of them staying in urban areas like Manhattan, LA. There's huge density of population in US in urban areas where the majority of focus is there, and rural not so much. The reason I'm stressing this urban and rural, you'll understand pretty soon. And some more statistics about India is that apparently it has been found out we use 11 GB of data on an average. It's not max, it's on an average. All of us use 11 GB of data per smartphone. It is apparently the highest in the world, but we are getting it at the cheapest rates in the world. So the average revenue per user, that is why these operators keep struggling, man. I mean, Jio, Airtel, Vodafone, apparently they're offering it as cheap as 8 rupees per GB, which is the cheapest in the world. I mean, why would anyone want to offer us for a cheap rate, right? Of course, they have to survive. But anyways, I mean, we are all happy. Hopefully, they will also figure out a way to survive. The government will help with policies or whatever. But at least from an end user perspective, we are all happy. 8 rupees per GB is the cheapest in the rate. Of course, anyone who knows the US rates, there's pretty much around like 70 rupees, if I'm not wrong. Not 70 rupees, it's around $60 per connection for, I think, maybe 5 GB per month, I guess. Quite costly in the US, at least from what I remember. And the primary workhorse for India is still 4G. Of course, there's no 5G yet. And all the operators are using TDD LTE, 20 megahertz per operator. And majority of the circles is still 5 megahertz spectrum. So what are we saying about 5G? We want 5G. So 4G is deployed in primarily in 1.8 and 2.1 gigahertz bands. The coverage is much better because of the lower frequencies. So 5G especially, it's being talked for at 3.5 gigahertz spectrum. And considering the technology that 5G is offering, we want around 60 to 100 megahertz per operator to get the best benefits of 5G. Like I said, mobile broadband is the primary source of internet. Then the other thing is the urban and rural Indian requirements are quite different. I will come to that and I'll explain in more detail. So what else is India focusing on? India is also focusing on IoT. For instance, if you see this article slightly outdated, I can't remember, okay, it is last year. It says Reliance Jio is planning to connect almost 1 billion devices via NB-IoT, and trust me, this is not a fake news, this is real news. I have been talking to Jio quite a bit about this technology, and they want to deploy several devices, almost from what I know, at least to start off with, they want to start with some 1 crore devices deployed around as a test trial, and then they will go full-fledged. And why does India need NB-IoT? I mean, there's a lot of electricity meters. You want to, like for instance, in this COVID situation, at least in our community, the electricity, the person who comes and reads my electricity meter, he has stopped coming from the last, I think the last 4 or 5 months during the lockdown, he hasn't come. And I think there was a lot of controversy on the bills that we have to pay. I mean, we can avoid all the situations if everything is smart, right? If I connect all these electricity meters with smart meters and billing directly goes to the cloud center and I get my bill, which is accurate rather than having such controversies. Yeah, see, if you see the second bullet point, the discoms were able to generate 95% billing efficiency during COVID. Apparently, there is a 1.2 million electricity smart meters already deployed by, I just forgot the full form of this, but I think it's some discom. And then 15 to 20% average increase in revenue because of this increased billing efficiency. So you won't miss, right? It is an automatic smart meter and it is automatically going. You get money well on time and then you can operate much better. And then with respect to IoT, we are just scratching the surface. There's a lot of applications, data analytics, AI. I think the best use case, at least in Hyderabad, that we have been talking about is video surveillance over in IoT systems in traffic places. I mean, connecting 1,000 smart webcams is okay, but actually in Hyderabad, the government was mentioning yesterday that there are around 5 lakh surveillance cameras in the city, and they want to increase this to 10 lakh surveillance cameras, double it. And how would you transfer all of this information from each camera back to the cloud center? You cannot lay a cable, right? There should be some wireless technology, all of them connecting to a cloud, and the cloud is connecting to a surveillance center. There's a lot of background technology. I think right now there's a small Wi-Fi based solutions that are out there, but I think to scale it up, cellular IoT technologies are quite crucial. And of course, there's a NASSCOM report which says IoT market is going to be huge in India. So these are main technologies that India is focusing on, and a lot of active work is going on across government circles and industry circles in India. So I've been talking a lot about, I stressed a lot about rural regions in the US or the developed countries versus India. So what is so special about Indian rural scenario? This is just another viewpoint. Please do not try to connect the TRI report with this. This is just some other company which has published its report in Times of India. The numbers may not be exactly correct, but you should just take out the gist of it. What it says is India is second largest rural consumer after China. It says there are 227 million rural Indian subscribers as opposed to 205 million urban subscribers. The first time India has more rural users than urban. I mean, if you want to club both of these reports, just assume that at least rural region is getting more popularity or as much popularity as an urban area in terms of cellular connectivity. So rural settings are quite important, especially because of this COVID situation. And significant investments will be made in this space. For instance, Airtel steps up to plan to boost 4G coverage in rural India. It's because of such numbers, right? They must also have some data analytics groups who must be telling them that, hey guys, please don't deprioritize your rural coverage. That is where most of your users are. If you do not, maybe Jio will take away all your customers. So please step up. So that's what Airtel is doing. This is also an article from maybe April or May. So what is the architecture that is there for Indian rural settings these days? This figure is courtesy Professor Radha from IIT Madras. So we have this concept of Gram Panchayats and villages in India. Just remember this figure and I'll explain you what is happening. So there is a big ambitious project that the government started a few years ago called as BharatNet. It's called Bharat Broadband Network Limited. You can just Google it up. What it says is that the cost of this project is 45,000 crore. The government is laying fiber, optical fiber, to each of these Gram Panchayats. Apparently, there are 2.5 lakh Gram Panchayats all across India. So Gram Panchayats are some nodal centers like these. So the government is connecting an optical fiber to each of these Gram Panchayats. The optical fiber is the backhaul in this case, right? It's connecting to the internet. Now, and once the Gram Panchayat is connected, they expect to deliver broadband to all of the villages that are coming under this Gram Panchayats. Okay. How? Let's see that. So this is a snapshot that I took yesterday from the BharatNet website. It says 4 lakh or close to 5 lakh kilometers of optical fiber. Wow. Of optical fiber cable has been laid. Almost more than 70% of villages or Gram Panchayats have been connected. So 1.6 lakh. And for which the final equipments have also been connected. By equipment, I mean this cellular tower like figure. Not just laying the optical fiber, some equipment has been connected, which is 1.5 lakh. So what it says, if you see the usage, I hope you can see my slide, but what it says on the usage side is, the Gram Panchayats for which agencies decide to install Wi-Fi is 1 lakh. Wi-Fi installed in Gram Panchayats, 93,000. Wi-Fi operational, 62,000. How many users? 13 lakh. And what is the total data usage per month? 11 lakhs GB. Oh, wow. Okay, amazing. These are mind-boggling numbers. I'm pretty sure none of us would have known about it before. But these are amazing initiatives that the government is taking. So the last point that I show on the left side is Wi-Fi is an interim solution. So basically, some only Wi-Fi access points have been installed in 1 lakh gram panchayats, and Wi-Fi is only an interim solution. I'll also tell you why Wi-Fi is an interim solution, because most of you who are from rural areas may know that the distance from your village to gram panchayat is quite huge, which may not be covered by a Wi-Fi access point. There are some solutions to still use Wi-Fi by using relays, but it may not be a scalable solution for the reason I will show in the next slide. So this is again another study done by Professor Radha from IIT Madras. This is from statistics available on internet. This website specifically, lgdirectory.gov.in. What it says is on the x-axis we have the distance distribution, the distance of a village from the gram panchayat, and the y-axis is the CDF. So what we are showing here is that 80% of the villages are within 4 kilometers of the gram panchayats. 90% of the villages are in 5 kilometers. 95% of the villages are 6 kilometers away from their gram panchayats. Now think, will Wi-Fi work in such a setting? I mean, sometimes Wi-Fi we are struggling because of the access points and all inside a home, or maybe in a office environment, depending on the kind of Wi-Fi routers you use. It may work within an office enterprise setting. Of course, maybe if you have much better equipment, it may reach further distance. But using Wi-Fi relays, maybe you can go further. But how well is it scalable? Like 6 kilometers, can I use Wi-Fi over 6 kilometers from the gram panchayat to the village which is 6 kilometers away? My initial thinking says no, but I will have to do a deeper study on this. I'm not really a Wi-Fi guy, I'm more of a cellular guy. So some statistics here. So radius of 3 kilometers covers 60%. The same thing what I said. So the last bullet point is what I want you to take home. So radius of 6 kilometers covers 95% of the villages. So some of you may have heard of this metric called intersite distance. So in a hexagonal layout, the distance from one base station to another base station is typically called as intersite distance. R is the radius of that hexagon site. So ISD is 6 square root of 3, 10 kilometers. Okay, so it basically what it tells us, two base stations can be 10.3 kilometers apart, then they can cover a radius of 6 kilometers properly. All right. So what is so problematic with 6 kilometer? So I'll tell you. So the current technologies, for instance, until 2018, whatever cellular technologies have been developed, they followed several models. So the technologies, I have some slides how technologies are being developed globally. For now, just bear with me and assume that, or just keep in mind that there are two standards bodies, two international bodies called ITU and 3GPP. So ITU is the United Nations organization, and 3GPP is mostly driven by companies. Big wigs like Ericsson, Nokia, Qualcomm, Huawei, and all drive 3GPP. So these two organizations usually define and ITU at the back channel. My understanding that I have seen over the last 3 years is again driven by 3GPP only. It's mostly companies that drive economies. For instance, Qualcomm or Samsung, for instance, in Korea provides around 35% of the GDP. So usually big companies drive economies, and they have a big say in what a government should say at a United Nations organization. So basically, bigwigs drive 3GPP, and in back channels, actually what happens is 3GPP drives ITU also. That's my understanding. You need not take me for as my word. So what these guys have done is, so far they have studied technologies for some configurations for rural areas. The kind of configurations they study for rural areas, I want you to look at these two highlighted points. They look at intersite distance of 1.732 kilometers, 1.7 kilometers. But in the previous slide, do you remember the intersite distance that was required for India is around 6 kilometers to be able to cover 95% of the villages. But these guys are saying, I will develop a technology assuming 1.7 kilometers. The next important aspect that I want you to see is this UE speed. They design technologies for users moving at 120 kmph and 500 kmph. Where in India do we see such huge speeds? I mean, these are possible in developed countries. For instance, in US, of course, in rural US, you can drive at 100 miles per hour. In mostly 80 to 90 miles per hour, which is around 80 times 1.6, right? Almost like 130 kilometer per hour. So these speeds make sense in developed countries. So this intersite distance also may make sense for developed countries. But these requirements are grossly underestimating what a developing country like India requires. So until 2018, there was no rural use case that suited the rural needs of a developing countries. So now you might think, what is the big deal? So actually you will see that designing a technology for 6 kilometer is hugely challenging as compared to 1.7 kilometer. It depends on the carrier frequency, it depends on the base station height, and then it depends on how a technology works in physical layer. For instance, what is the signal to noise ratio that I can support at 6 kilometer versus what is the signal to noise ratio I can support at 1.7 kilometers. As you may rightly know, because of path loss and all at a particular frequency, the SNR at 1.7 kilometers will be much higher as compared to 6 kilometer under similar settings, right? That means if I have to design a technology for 6 kilometer, the physical layer, the MAC layer, etc., they should have inbuilt technology to support cellular technology that supports low SNR as a minus 15 dB, minus 18 dB, something like that. But by doing such a metric, by taking such a metric as 1.7 kilometers, these standard organizations develop a technology with an SNR which is typically around minus 6 dB. That means in India, this technology won't work. It just won't work. So what happened? So the IMT advanced technology, for instance, in 4G, where such requirements that I show in the table have been used, do not meet rural requirements of countries like India. What happens because of this? This is an article from a very good friend of mine, Sendel from Ericsson. What they have written recently, this is last week, rural connectivity, some challenges and opportunities. They tie it up to something called as a business case. So let's quickly read it. So rural connectivity poses two challenges for operators. On one hand, the cost of deploying and maintaining sites in rural and remote areas. Rural is typical villages. Remote is something like a mountain area or something which is like a tribal area which is deep inside some forest where not everyone can go regularly, something like that. Okay. These sites can be significantly high. On the other hand, the revenue per user can be low, especially when compared to urban and suburban areas. In short, the business case is weak. So an operator, if you see this plots here, the cost for an urban versus rural versus remote area, apparently there's 18% higher cost in rural and 35% higher cost in remote areas. So why would any operator want to go and do something fancy for an Indian rural area? And think about it, if I develop a technology for 1.7 kilometer and then I have to deploy for something like this for 6 kilometer. So 1.7, 6 divided by 1.7, approximately, let's say 3 times. So I have to, not just one site, I have to develop 3 sites, 3 cell sites to cover that 6 kilometer radius. Oh my God, I can't even imagine what the cost of such a network would be. So if you design a technology considering developed countries in mind like this, it is definitely going to impact what is happening in India. That is what has happened predominantly in 2G, 3G, 4G. That is why India always lags behind. India lagged behind. Lagged. It's not lagging anymore. It just lagged behind for all of these reasons. You may think, why India is just slow. No, it's not slow. There's a lot of things happening outside India which are out beyond our control and which we really did not know before. India has risen very recently from the last 4 or 5 years and we are changing things. And that is what's happening now. So things are changing. So what have we started doing? So India's journey at first one such organization called 3GPP, which is an international body. So this is a photo that was circulated around 2017, and me and several of the Indian colleagues will also be involved in all of these activities. This was when the first version of 5G got released. It was a marathon, 9 months, 10, maybe wait, 2016 March to 2017 December. Okay, close to 2 years. A marathon effort to design 5G. Actually, 4G, if you know, it took almost around 3 years to develop. It was slow. There was not as much interest. There was not as much push. But 5G went on a rampage. It was like jam-packed, and 5G was designed. Although the research started way back in 2012, I would say, but the standardization began in 2016, and it's still going on. But the first version of 5G came out in December 2017. So as part of this group, India played a huge role. IIT Hyderabad was the brand and is still the brand at 3GPP. We have a huge power. We have partners like IIT Madras, a research organization called CIVIT. Reliance Jio very much helps us. And there's another organization, Tejas Networks, that has helped us to achieve several goals at this organization, 3GPP. We have submitted around 300, 400 contributions in several technologies like narrowband IoT and 5G release 15, 16, 17. I lead the release 16 and 17 efforts that I am doing. I lead these organizations in these meetings. Of course, there are other topics that we are also being covered by this organization, CIVIT. One of our claim to fame by Professor Kiran is a new waveform was introduced in this technology 5G. It's called pi/2 BPSK with spectrum shaping, which is the core element of our standard, which I will talk in the next few slides. I will also explain this. And I am the one leading this release 16 and release 17 efforts. So, like I told you, if you remember that table, if you do not contribute to these organizations will not take into consideration our requirements, and the technology will be developed with some other requirements. And again, India's requirements will be ignored. That is what we are trying to avoid. So this pi/2 BPSK waveform, it's a low PAPR waveform with a DFT spread or SCFDM waveform. What we have shown is that by using such a waveform, we can increase the uplink power by 6 dB compared to OFDM waveforms. Increasing an uplink power, like for instance, right, you know the path loss equations. It is transmit power minus the path loss and shadowing, etc. So if I increase the transmit power, the link budget directly increases. So Professor Kiran has designed this waveform over several years of research. He has designed a waveform called pi/2 BPSK with spectrum shaping, where we were able to drive the power amplifiers to full utility without saturation, and we have shown that the coverage can be improved by almost 100% without any need for a higher power amplifier. I mean, these are the technical details. That's okay. We can do it some other time. These are just proving that this waveform is much better when compared to other waveforms that are out there. And this is a press release that India's first 5G patent tabled before the world body, which is 3GPP. You will see all the main organizations, IIT Hyderabad, CIVIT, IIT Madras, which is the pi/2 BPSK waveform that we have pushed. All of these organizations, I mean, getting your patents into these standards is a big deal. Of course, a technology is built by several patents. So Qualcomm has patents, Huawei has patents, Ericsson has patents, and there's a patent deals that happen between these MNCs. And for us to research organizations to get, see, I mean, we are not doing academic work. Think about it. We are fighting with all the big wigs here, like Ericsson's, Nokia's and all, and we have put some industry grade technology into a standard. Think about how many people are doing that in India. We have to improve this in India. All of this is happening in India. This was back in 2017 where the efforts, I mean, if we achieved in 2017, it means the effort started much before. So that is India's journey at 3GPP, and we are continuing it. We are actively contributing to 5G advanced
Yeah,
releases.
Dr. Dheeraj,
Yes, please.
are we going to cover this particular PPSK technology sometime later? Are you going to
Sir,
elaborate that?
I have not.
Sir, I will answer that. So basically, we have one session planned on Wednesday for 5G waveform design. So,
Okay.
so we'll do that. And Sai sir, you may please continue. Sorry for the interruption.
No problem. Yeah. Sorry. I mean, if you have questions on that, you can drop me an email. But this one, I just wanted to highlight what India has been doing, more like what we all should feel proud about that we have been doing. Okay. I'm sorry, I'm not going into too technical deep details.
Sir, that's
So
fine.
there is
because,
another organization.
Yeah, go ahead, sir. Go ahead.
Yeah. So there is another organization that I mentioned, which is quite crucial. So actually, we as researchers in India, we have realized the importance of these organizations only, I would say, only 4 or 5 years ago. Really, there was no such mindset in India, and the importance of what such organizations play, it has hit us very late. And I would say it is thanks to efforts by Professor Kiran Kuchi, Professor Radhakrishna from IIT Madras, and a lot of support from Department of Telecom. I'll highlight all the people soon that we have been able to do this. So the second organization that I want you to be aware of is this ITU, International Telecommunications Union. It is a United Nations body. And what is United Nations? United Nations is an organization made up of countries, not companies or organizations. It is countries. Countries drive UN. Right? It is 1865, blah, blah, blah. ITU, they do a lot of spectrum harmonization. They tell that this is the sort of spectrum that each country can use. This spectrum can be used for space. This spectrum can be used for 5G. Right now, there is a lot of talk going on about the millimeter wave spectrum in ITU. The millimeter wave spectrum, for instance, 24 to 28 gigahertz of spectrum. For instance, bigwigs like Samsung is pushing Korea and also in US to make this millimeter wave spectrum available for cellular. But we have a unique challenge because ISRO in India is using this for their space activities. So ISRO wants to be a little careful about releasing this spectrum. See, for instance, you might think that let's let India stay away from such a decision. No, man, it's going to be a big problem for India if its neighboring countries are going to use such spectrum. If neighboring countries are going to use wireless transmissions in this millimeter wave spectrum, it's going to affect our satellites. That is what every decision plays a big role in government like ISRO, in technology. I mean, this decision will, of course, impact 5G deployments in India. There are so many things interconnected. Just, I would really request all of you to say that India is lagging behind in technology. No, there are so many things that happen which drives India's strategy. You might say that India is delaying 5G spectrum trials. No, there are so many other things like China, that's the border issues, the Huawei issue. There's so many things that we have to take care of about that you and I do not know. There's geopolitical issues, there's border issues, there's technology issues, there are patent issues. We have to know that all of these impact how a technology gets adopted in a country. So getting back, this Telecommunications Union, ITU, it also defines standards, not standards, it also broadly defines how a particular generation technology should look like. For instance, what is 3G going to look like? What is 4G going to look like? And what is 5G going to look like? And approximately they take 10 years for each technology. In between this, once they define, there is research that happens by academic institutions. And once research is done by academic institutions and industries take it up and they define a technology. And for instance, what they do for 5G, this was back in probably 2015, 2016 time frame. ITU has started this study. I will show you a timeline. So what they said was 5G at a very big scale. You all must have seen the triangle of 5G, right? EMBB, URLLC, and massive machine type communication. That figure came up from ITU. So what it tells is that now, guys, we should develop a technology which is broadly going to cover these 3 points at the triangle. It should cover this mobile broadband. I want Gbps of data. I want to cover 1 million devices. I want to achieve a latency of 1 millisecond. That's all it does. ITU defines that broadly. Hey guys, let's define a technology. Let's generate a new technology which will achieve such and such goals. ITU does not look into the technical aspects. It just says that broadly, please go and create a technology which will look like this and the whole world will benefit. Why is ITU doing it? It wants the world to benefit. At least that's what they claim. Now you have to question yourself, if ITU is driven by countries and it is not really looking at technology, then how does it come up with this triangle, 1 Gbps, 1 millisecond? Think about it, just go back and think. It's again driven by companies. So companies drive countries' decisions, countries drive UN's decision. Okay, that is how all of that happened. Now again come back to think about what is happening in India. Do we really have a big company in India that is going to drive a technology that India can influence at UN? At least until 4G, we did not have. We only had companies that came from outside and set base in India, and they are using Indian resources for their own benefit. I'm not saying that's bad. It's good. We are all getting jobs. But what is India gaining? I mean, from a technology perspective, from a technology leadership perspective, India may have not yet gained as much. So DRDO and ISRO, they don't participate because they have different agendas. So we need more like private organizations. So what are the private organizations? Think about it. There were companies like Tejas or very recently Geo. They have come up very slowly. They are now building up. Tejas as a company. Maybe there are other companies which I'm missing, but these are people I work with. So I'm just giving those examples. So these companies, Geo is massively ramping up now. It's very recent, right? It wasn't there until 4G. So basically, Geo did not have an opportunity to manipulate is the wrong word, to influence the 4G standards. Same thing with Tejas. Tejas was more like an optical fiber company with a very small business interest in 5G cellular company, but they are also changing. So really, we did not have a claim to fame big name who could drive India's standards, India's position at such an organization. So India really did not contribute much until 4G. But bang on, we just started changing things in 5G. These Indian researchers, Professor Kiran, Professor Radha with the DOT, we have realized that India has to change. And we have started doing that from 5G. I'll tell you the timeline, just hold on to that thought. So some more introduction to 3GPP, ITU and our local body. So ITU defines the requirements. 3GPP is an organization which is driven by companies, which makes the standards like 5G, 4G, etc. And 3GPP itself is broadly driven by 7 organizations in different countries. ATIS in USA, Arab in Japan, TTC in Japan again, TTA in Korea, ETSI in Europe, CCSA in China. And recently in 2015, we started an organization called TSDSI, Telecommunications and Standards Development Society of India. So we started an organization in 2015, not me, I'm sorry, I wasn't in India back then. I was just finishing my PhD when this happened. This organization was started in India. So basically what happens is several companies register to these 7 entities, and these 7 entities together form 3GPP. And if a technology has to be driven by 3GPP, these 7 organizations have a big say. Now, again, before TSDSI was there was only 6 organizations, and again, India was never in picture. Now that TSDSI was formed in 2015, all Indian organizations, all research organizations in India have started becoming members of this TSDSI. And now we are driving some standards in 3GPP. So every single thing matters, every single thing. So now if a standard society was formed in India, that is impacting 3GPP, and 3GPP is directly impacting ITU. That is how India has started influencing global standards. So for instance, this is just a 3GPP PPP timeline, which is saying in 2016 it has started 5G, and then 2021, 2022 it is still continuing. Release 15 is the first release of 5G, which has started some deployments across the world. Release 16 has been done in June 2020. Now we are working on release 17. So in terms of this standards, there are two main tracks that I want to talk about. So where we have impacted ITU. Just recall, this journey is India's journey at ITU. In ITU, we made two big contributions. If some of you may have been following India's research, you may have a word called LMLC, Low Mobility Lab Cell. And this could be an obscure word for most of you. It's called an RIT. I'll explain to you. So basically, there are two parallel tracks here, LMLC and RIT. So credits should go where they are due. Professor Radhakrishna Ganti started this LMLC efforts from IIT Madras in 2016. And TSDSA RIT, I was one of the major contributors, and I, along with Professor Ganti, we led this team for TSDSA. So I'll talk about both of these. So now, Dr. Shahjahan, is it okay if I stretch beyond 11?
Yes, sir. But how long would it be?
Maybe 11:10, maybe.
Okay, sir. Okay, no problem. Go ahead, sir, please.
Yeah, or maybe I'll just try to rush so I can finish.
No, sir, it's
so
all right,
the
sir.
basic architecture
Okay.
I won't repeat. So this. Okay, thanks. Yeah. So I guess you all by now remember this architecture of Gram Panchayats and villages. So this was our motivation to change something at ITU. So we showed this statistic at the ITU meeting. We, as in Professor Ganti, led the team. So after showing this statistic, we told that, guys, please change your attitude. Please change your thinking. What you're designing is not going to work for India. We have to look at India. We need a technology which works for the intersite distances that we have shown here. For instance, we need an intersite distance of, let's say, 12 kilometers. That's where we started. We started off initially by saying that we need an intersite distance of 12 kilometers, which is a radius of approximately 7 kilometers. But of course, there was a lot of back and forth, and these technology bodies, they knew that designing a technology for such a long distance was very, very painful. For instance, 4G did not have that capability, and designing a new technology that will suddenly shoot up from 1.7 kilometers to 12 kilometers, they knew it was beyond their game. It was not possible. So as a compromise, if you see this highlighted text, we managed to say that a technology should be designed for at least an ISD of 6 kilometer. So look at this. ISD of 6 kilometer means a radius of 3 kilometer. It just says that still only 60% of the Indian villages can be covered when I deploy a base station at the Gram Panchayat. So still there are 40% of villages that are not covered. So this is the best we could achieve, because it's a compromise, right? We have been fighting a lot here in this fight. Actually, the government of India also supported by deploying the Department of Telecommunications personnel. We, the researchers from India and the DOT, we fought with other companies, other organizations, other countries to gather multi-country support. There were several countries that I'm not sure if I can mention their name. They have supported us. For instance, several developing countries, they supported our proposal and they said 12 kilometers is required, but eventually it got watered down to 6 kilometers. So what it says is, any technology that you guys, like for what UN body, ITU said that, guys, whatever technology you guys are going to develop, it should definitely support 6 kilometer ISD. It's a big achievement from 1.7 kilometers. So in technology, so whenever you design a technology, so this UN body will approve its technology by looking at its merits. Okay, when you look at the merits, it should satisfy certain criteria. The criteria, for instance, have been like this for rural case. In rural broadband, rural EMBB means rural enhanced mobile broadband. The evaluations must happen in certain settings like this. For instance, in 700 megahertz band, when the base station is 35 meters with a certain power, it should satisfy an intersite distance of 1.7 kilometers. And they say that in such a deployment scenario, the average data rate should be some X Gbps, or let's say cell edge data rate should be 100 Mbps, something like that. So now India managed to put in such a column which says, I hope you can see it, it's called LMLC, low mobility large cell. You remember the 500 km per hour that I showed earlier? That doesn't work for India. So that's why we said it should be low mobility, means 30 km per hour range. And then large cell in terms of what was already existing, like 1.7 kilometers. So we said 6 kilometers. I mean, we wanted 12, but at least 6 kilometers got agreed. So that is what low mobility large cell. So first thing we achieved in ITU was any technology that is going to be developed for IMT 2020 should satisfy such test requirements. If it does not, then that technology will not be called as an IMT 2020 technology. So for instance, some more evaluation criteria, like for that scenario, for downlink, the spectral efficiency should be something like 3.3, 1.6, etc. So basically, if you are interested, you can look at this report. It's called ITUR M241. Just something similar again. These are the different kinds of testings that a technology has to pass as per United Nations ITU. So for mobile broadband, it has to satisfy in indoor. There are certain requirements. In dense urban settings, it has to satisfy something. In rural settings, it has to satisfy. For massive IoT, massive machine type communication in an urban setting, there will be like in a particular region, I should support 1 million devices, etc. In low latency, there is a specific setting called urban macro. Anyways, you can look at details. And what I wanted to highlight is this green thing below, which is our test setting. Low mobility large cell, 700 megahertz, 6 kilometer and 30 kilometer. And this was actually the timeline that IMT, the United Nations ITU followed. It all started way back in 2016 and it's still going on. So India started participating in, if I'm not wrong, somewhere around number 25 meeting. So then we started with this LMLC proposal. Then in 2016, 2017, we were also participating as part of 3GPP standard. But then several things happened and some of the proposals from India were not accepted in 3GPP. And then that's when we decided we will make our own standard for India. India now has a standard called TSDSI 5G standard. You remember the other organization that I talked about, India's organization, India Standard. I'm sorry, India Standards Organization, Telecoms Society for Development, Telecom Standards Development Society of India. So what we did was we took the 3GPP's 5G standard and we added some Indian enhancements like pi/2 BPSK waveform. And then we said that, yeah, I'm sorry, maybe I should tell that. So United Nations organization, going back to this, what it says is that it's actually a very long process. It's an 8-step process. It invites organizations, entities, countries, everyone to submit technologies for ratification as an IMT 2020 standard. So people who know about 4G or IMT advanced, there were two standards that were fighting for IMT advanced stamp. One was WiMAX, the other was 4G. WiMAX was driven by the IEEE society and 4G was LT was driven by the 3GPP society. Both of them were fighting and both of them were stamped as IMT advanced standards, but of course WiMAX fizzled out because of business and other concerns. Something similarly, this ITU organization invited several people to submit potential proposals for approval as an IMT 2020 technology. IMT 2020 technology is something, if you remember, I told, right? It should have that triangle, it should satisfy all the criterion for that triangle, 5G triangle. So taking this into cue, we also submitted a proposal to this United Nations body on behalf of this society, TSDSI. So this is a press article. So India's 5G technology called TSDSA RIT. RIT means Radio Interface Technology. Moves another step forward. So as of last, sorry. Okay. This is fresh news from last Friday. So our standard TSDSI RIT is radio interface technology. Radio interface technology means it's a cellular technology that it's called radio because it's communicating over the air. So it cleared 8-step process at the United Nations organization. We actually named our technology as 5GI. It's called 5G India or 5G Improved. And there were only 2 technologies across the world which passed this evaluation and are being stamped as IMT 2020 standards. One is from India, TSDSI. The other is by this global body called 3GPP. So credit to Professor Radha for leading this team from the front. So I have extensively contributed for this. I have designed the technology, the specifications and etc. for this submission to United Nations. So if you see, there are 2 things here. The following are approved. There are 2 submissions from 3GPP and 1 submission from India called as 5GI. So these standards are now globally approved and they are called as IMT 2020. So just remember these words. There are so many terms. One is 5G, one is IMT 2020. 5G is more like a business terminology that is designed by this body called 3GPP companies. But from a United Nations perspective, they don't call it as 5G, they call it as an IMT 2020 standard. So some of you may have heard that 4G is also called as IMT Advanced. IMT Advanced and 4G, IMT 2020 and 5G. So from India's perspective, we have designed a standard called 5GI and it is now a IMT 2020 standard. That means any country in the world, if it wants to deploy an IMT 2020 standard, they have 2 options now. They can look at either our option or the 3GPP's option. India's option or 3GPP's option. It's a proud moment for India. Lot and lot of support has come from Department of Telecommunications, the then Secretary Madam Aruna Sundararajan, now Secretary Sri Anshu Prakash ji, and several other personnel from DOT. Several researchers from IIT Hyderabad, IIT Madras, and Geo has helped us, Tejas has helped us to achieve this massive step. So this is the backside story of what India has been doing from 2016 until now. 2015, I would say precise, because of this society had to be formed, TSDSI, and then 2016, from the time we started working technically of all of this. So India has started 5G work almost 5 years ago, not now. So this is all the standards work, okay? So standards are very important to develop a technology. Now someone has to implement it. So what is going on in terms of implementation? So in 2018, early 2018, or maybe late 2017, a consortium of IITs that you see on the slide and a research organization called Samir and Civit, we have submitted a proposal to Department of Telecommunications to build an end-to-end 5G testbed. It's a collaborative project, and this announcement was made by Mr. Arun Jaitley in Parliament that the government is granting a 240 crore project to these institutions to develop an end-to-end 5G testbed so that we can build more startups in India, multiply the R&D capability and technological prowess of India, and enhance the capacity of 5G in India. Also increase India's participation in global forums in 3GPP, ITU, etc. You will be surprised to see that after India started its testbed on 5G, there are 4 testbed programs that were started in US. It was after India did it. It's actually, we started testbed and we are at a much advanced stage than where US organizations are. Now, I'm not talking about companies like Qualcomm. I'm talking about a government in US funding testbeds like DARPA testbed or a DoD, Department of Defense testbed. So India has done a 5G testbed program much before than US. You should again be proud of it. So what are we developing across several institutions? We are designing a massive MIMO subsystem for 64 antennas to support 5G. Then we are doing a millimeter wave support for 5G. Then we are designing a 5G modem for supporting sub-6 and millimeter wave as per the 5G NR specifications. And of course, a core network. These are all the various subsystems that we are developing. We are developing core network. We are doing user devices, remote radio heads, baseband modem, etc. A lot of them we are working on. At IIT Hyderabad, right now we have some setups which are working like this. We have a 5G base station and a 5G UV that we have developed, which are talking to each other right now at physical layer, achieving Gbps of data rates. Then we have we have several test equipments, industry grade test equipments with which we test our designs. So we have a 5G base station, which is split as a DU, RU, and talking to our test equipment and decoding real-time information. We have one of the world's first massive MIMO testbed where we have designed several new algorithms. We have displayed this at several places outside in India Mobile Congress. Here you see Secretary and Minister looking at our demos. It's a massive MIMO 48 antenna setup that we have at IIT Hyderabad. So a lot of R&D is going on, industry grade R&D, not just academic R&D. We are doing industry grade R&D because we talk to a lot of companies. We have third party equipment which are quite costly. If we cannot prove our technology with these third party equipment, then it's of no use. So we are designing all industry grade designs at IIT Hyderabad, and YSIG, which is the startup at IIT Hyderabad, is also helping us. So far you have looked at a standards perspective, standards where technology is being developed over which we have started in 2015, 2016 timeframe. Over 4-5 years, India has been doing amazing stuff. And then we are from 2018, early 2018, we have also been developing these standards on real-time platforms like FPGAs, DSPs, x86, whatever, and showing industry grade solutions. What really is the path forward? It's a very short take on it. So India government, there is a lot of news about India awarding 5G spectrum, whatever. Personal view, I think India should move a little fast on it by considering, of course, all the geopolitical issues. India can take a stand. It should award the spectrum. The reason I say it should award the spectrum, or at least what it should do, is it should start field trials in India. The reason field trials, there was a news, I saw a ridiculous piece of article. See, one thing is, most of the newspaper articles that you see, you should be very careful about. These are all written by some MNCs with hidden agendas saying. There was a ridiculous piece of article that I saw that someone, I don't want to mention the company, that company said, there is no need of field trials in India, 5G is already proven outside. What are you talking about, dude? Just like I told you, whatever is developed for other countries may not work in India. The landscape in India is much different. The way 5G behaves in India is much different from way 5G behaves in US. We need to know how 5G behaves in India. Just go and do the trials. Tell us how it is working, what new enhancements are required. Tell us what India-specific things have to be done. That is precisely what we have done with our 5G standard, which is called 5Gi. So what I think is, personally, 5G trials should happen as quick as possible in India. And India should be prepared, come what may. There's a lot of high-level forums that Professor Paul Raj is part of, Madam Aruna Sundararajan, Professor Bhaskar Ramurthy. They're all working day and night to ensure that India's interests are not compromised, and India will be on par in 5G with respect to other countries, considering all other issues that are happening across the globe. Across India. Okay, it's not an easy thing. India has to be careful. Just don't complain that India is not doing much. India is doing a lot, much better than several other countries that we all know. Yeah, so this is the end of my talk. India is doing great. It will do great. It will continue to do great. And people like you should contribute in it. Please come forward, contribute to India's success. Thank you. Yeah, that's the end of my talk. Yeah.
Thank you so much, sir. In fact, it was a motivating talk, and it has really put things in perspective as far as the FDP is concerned. So thank you for that. Now we'll begin taking questions, if you don't mind.
Yes, sure.
Okay. So one of the comments over here was that one Madam Deepa, I hope she's still on board. So basically, she wanted you to move to a particular slide. I think it was the one in which you were comparing waveforms, if I'm not mistaken.
Okay.
Yeah, Madam Deepa, are you there?
Yes, sir.
Okay. So, sir, could you please
Yes,
move on to that?
yes.
I think you will have to share your slides once again.
Yeah. Here. I think it should be visible.
Yes, sir, it is visible.
Yeah, I think this is the slide that you wanted some clarification on,
Yes,
madam.
sir. Yes, sir.
Yeah, please go ahead and raise your query.
Thank you for your wonderful presentation, sir. Sir, in this slide, you have mentioned that
Yes.
PI by 2 BPSK compared to OFDM. OFDM is a multi-carrier modulation technique, sir.
Yes. Yes.
Why it's compared with OFDM, sir? Because BPSK it's a normal
So,
modulation scheme.
no. Yeah. So maybe the terminology is a bit loose. So basically, there are two waveforms that are typically used for 4G and 5G. One is single carrier FDM, if you know, DFT spread OFDM, and the other is a regular OFDM. There's a difference between these two waveforms. Pi by 2 BPSK is the modulation that is used on top of the DFTS OFDM waveform. So sorry, the terminology could be a bit loose, but it is Pi by 2 BPSK modulation on DFT spread OFDM waveform.
Okay, sir. Okay. Thank you, sir. Thank you. What about the
versus the multi-carrier OFDM waveform?
Okay, sir. Sir,
the spectral efficiency will be, I understand. Yeah, the spectral efficiency will be as per Pi by 2 BPSK only. But the motivation for this is, for instance, is to improve the cell coverage. So what we are showing, if you will actually Google up IIT contributions in 3GPP, so you typically at a cell edge, so for instance, to make a WhatsApp voice call or a WhatsApp video call, what we have shown is that this Pi by 2 BPSK spectral efficiency is enough at like 12 or 30 kilometer away from the cell edge with 5G technology. Of course, you will not be able to get GBPS of data rates. No, that is not the goal. What we are saying is, at least you should be able to make a great WhatsApp voice call. So that is coverage. Coverage means I'm not expecting GBPS of data rates at cell edge. I'm expecting that I should not lose connectivity. That is the entire motivation of this talk. So of course, there are two main tracks for any technology. One is capacity, the other is coverage. Data rates, of course, you need to be closer to the cell to have a better signal to noise ratio and get GBPS of data rate with higher order modulations like 64 QAM, 256 QAM, etc. But when I move away from the cell, the SNR is very low. It is going lower and lower, like minus 10 dB, minus 12 dB. There I cannot support higher order modulations. There, all that I can think of is lower order modulations like Pi by 2 BPSK or QPSK. And with those modulations, what can I do? At best, I want to ensure that I'm still connected with a voice call and I can make emergency calls and I can still talk to my loved one without having any loss of connectivity. So that is the goal of this proposal. We want to ensure that the last person at the furthest distance from the base station can still make a WhatsApp voice call. That is what we have been pushing.
Thank you, sir. A few more queries over here that we will take if you have some time. One of the queries is I think regarding the likely spectrum in which 5G will be operating in India. So the specific question is, what will be the frequency bands that will be deployed? So are there any indications to that, sir?
So government is in India also people are pushing for millimeter wave spectrum. Precisely the reason why companies push for millimeter wave spectrum in India is because they have a technology that is proven in countries like Korea. For instance, Korea already has 28 gigahertz millimeter wave already deployed with several towers and all. For instance, Samsung wants to use that same technology in India. So Samsung is pushing Indian government to release 28 gigahertz in India. But of course, ISRO, World Radio Congress, they're all talking about it. So that is one spectrum that a lot of talks are happening in India. The other common spectrum across the globe is 3.5 gigahertz, which India is also thinking about. So these are two main spectrums that mostly 5G will be deployed at. Because all the lower end spectrums are all fully occupied, and 4G won't go away so far. So 4G is already occupying it. Unless you remove 2G and then 4G moves into a 2G band, and then maybe 5G can move to a 4G band. There's a lot of spectrum reforming that may have to be done. Again, it will take some time. Because, for instance, there was an article by Jio which said 2G should be removed in India. I mean, I agree with it. But of course, Airtel did not want it because Airtel has a lot of investment in 2G. Unless, I mean, in my personal perspective, if you do not get away from older technologies, there is no way you will start making space for new technologies. A lot of money issues and all come into picture. But predominantly, I think the spectrum, I mean, getting back to the question, I think the two main spectrums being discussed in India are 3.5 and 28.
All right, sir. Thank you. And one more question is there that you spoke about setting up 5G testbed and industry grade with industry grade equipment. Now, the question here is whether these devices would require us to, would we require to be imported from outside, or is it indigenous? Is there any effort to have indigenous products? 5G?
Very great question. Very great question. So right now, yes, we are depending on outside companies for this hardware. But then there is a great effort being driven in IIT Madras to develop processors in India. They have Shakti processors, if you know, and there are several other companies. I'm not sure if I can name them, but they are also designing some processors. If these, there are initiatives, it will take some time. If these come up, I mean, over the next few periods, maybe 5G advanced or 6G, we can develop on this Indian hardware also. And Indian hardware is very critical for India's national security interests also. Good question. It will happen sometime soon, but hardware is a lot more effort than software. It will happen sometime soon. Something like this should happen for hardware also. But Professor Kamakoti from IIT Madras is already leading this effort. Trust me, it's happening and it will happen.
Okay, thank you, sir. I think the other question regarding adaptive modulation and coding we could address in one of the future sessions, sir. So Dr. Buddhaditya, maybe please take note of that. There is a dedicated session for that. If there are no other queries, I think one more query has come in regarding which kits we can use for taking practicals. So Sai sir, if you wouldn't mind, we will be informing participants. We have several sessions wherein we will be guiding them in how to set up test beds. So I think we will, yes. So I think we will wind up the session now. And on behalf of all the participants, I thank you, sir, for presenting today and for being on the forefront of the 5G initiative in India. Also on behalf of Atal, Goa College of Engineering, in fact, Principal sir had to leave in between due to another meeting. He has told me to convey convey his thanks. So I am doing that on his behalf. So I thank you, sir, on behalf of Atal, Goa College of Engineering and Department of Electronics and Telecommunication. So thank you very much, sir, for your talk.